Hello, everyone. For the very beginning, a few words about me, but it will be easier to understand where I'm coming from. I'm an independent open source contributor and advisor, Airflow committer and PMC member, Apache Airflow, because the whole presentation is about Apache Airflow. I'm also a member of Apache Software Foundation, and I'm one of the few lucky people who work full-time on open source and get paid for it, and that's awesome. I can recommend that. What I'm going to talk about today, first I will tell you a little bit about Apache Airflow, what it is, not a lot, just to know so that you know what it is if you don't know it. I will tell all about dependencies, like some basics about dependencies, so that we also understand where we are with this. And I explain why Apache Airflow is different than most of the application and libraries you met, but also like why in the future you will see more things like Airflow. And finally, I'll tell the challenges we had with Airflow, the solutions that we applied for dependency management, and some benefits we got out of that. So first of all, Airflow. Airflow is an orchestrator of data processing. Who knows Airflow here? Who used Airflow? A few people. Okay, good. So Airflow is nothing more than a conductor or orchestrator that tells others what to do. So when you have a huge data pipeline processing, and there are different services, different processing elements, or like Spark and Kubernetes and others, Airflow will organize the work of pushing the data through the pipeline and make it well organized in scheduled way. So it's basically cron, if you know what cron is. But this cron allows very complex relationships between components and passing data between each other and managing that data. So this is Airflow. But what's really important and why we are here on PyWaw, like Airflow is really all about Python. So Airflow from the ground up was created in the way that everything you do with Airflow you do with Python. So you develop all the relationships of the data pipelines, or all the communication with the external services. Everything is written in Python. It has some libraries, it has some classes that you can import and run, but you don't define those relationships in any graphical way of any sorts. You just write the Python code and execute the Python code. And this is like you can do everything with Python, and in Airflow it's especially so. Dependency mess or dependency hell, whatever people know it. There are like super different ways of running or using dependencies in Airflow or installing in Python. You mentioned at the previous talk pip install as usual. Yes, most people use pip install, but when those dependencies grow beyond like 1 or 2 or 3 dependencies, you start to think about using other tools like pipenv, piptools, Poetry. Who use Poetry, for example, for their dependencies? Yeah, who uses pip for their dependencies? I would expect everyone, and there are many others. Yeah. And also you can keep the dependencies in many places like setuptools, setupcfg, requirements.txt. There's a pip file, there's manifest in, there are log files introduced by Poetry. At the end, what you get basically when you approach Python dependencies, you get something like that. Your virtual envs and all the dependencies are looking more or less like that. Anyone recognize this kind of picture from their own environment? I certainly do. Yeah. So this is exactly what you end up with. However, when you look a little bit closer, and that's what the creators of Poetry and other tools like that figured out, that there are 2 types of dependency management that you can imagine in Python. One is for applications and one is for libraries, and you manage dependencies a little bit differently for those 2. Why? For applications, generally you install your application in the application's virtual environment. There is even a pipx tool which does exactly that. It takes application, all the dependencies, and creates a separate virtual environment, and then you can run your application completely independent on any other environments that you have. You expect the application to install consistently over time. So if you install it today, you want in 2 weeks or 2 months, you expect that you do the same command to install, that it will install and it will not break. You don't usually manage upgrade of dependencies automatically, because your application expects dependencies in a certain version, and the application knows what dependencies it wants. So more or less what you end up when you want to install application is the dependencies which are pinned. This is the name, pinned dependencies. So you know all the dependencies you're going to use, and they are in a specific version that you know they will work with your application. However, when you have library, this is a bit different story, because when you have library, you expect to be installed in others' virtual environment, not in your own. So you don't kind of manage it. Somebody manages it for you. So, so whenever you use some dependencies, probably you would like to use new versions of those dependencies, which are also installed, so that there are no conflicts. Because if you pin your dependency like an application, and somebody wants to use different version, you have dependency conflicts. So you want to avoid conflicts. Usually, your library expects the dependencies to be updated for it by someone else, like the application, when it is upgraded. And usually, you have some kind of dependency resolver that figures out the dependencies. And there, maybe it's not very, very visible, but there is this an example dependency when you specify just ranges. Okay, I work with this dependency, not bigger than that or bigger than that, or combined. Or for this Python version, you specify, okay, this is the version that I'm going to use. And then some magic must happen when you install a complex application, and I will tell a little bit why Airflow is complex in a moment. Then you have to tell, okay, so this is the set of dependencies that satisfies all the requirements from all the different libraries we have. And this is so-called dependency resolver. And in case you didn't know, last year PIP included a real dependency resolver in their version, which caused a lot of troubles for Airflow. We worked with the PIP maintainers to solve them, and it's getting better and better. So I would recommend using the latest version of PIP, because the dependency resolver there is getting better and better. So there are two different approaches, but also there is one other thing which kind of combines those two. Because when you develop a library or dependency or application, you want to develop it. So this whole set of dependencies will change over time, because you will add new. Somebody else in the same team will add another dependency, and this will all evolve. However, you want to so we will keep like separate virtual and for each configuration you have. So because you can have like a working version for Python 3.6, 3.7, 3.8, those are all separate. Each developer has its own development environment, and they can have different dependencies installed there. You don't control that, especially if you have a library that has a range. Okay, I can have like 1.6 and somebody else 1.7. They all fit the range, but the behavior of application installed in this environment, it might be different. So we very often tend to get into this works for me syndrome. Yeah, I run the test, they work fine. I run the test at the other environment. The other developer at the other end of the world sometimes runs the test. It doesn't work. Why? At the end, it turns out that I had the dependency 1.5.7 and he had 1.5.6, and that was one of the 100 dependencies we had. So those are the differences between our environment. So what you tend to do at the end for development, you somehow kind of lock the dependencies for the time of development. This is more or less what Poetry is doing with the log file. And there are other approaches like that. So basically, what you end up at some point of time, there is a golden set of dependencies in your repository. Those are the dependencies that your tests are working with. This is cool, yeah. And then there is it creates a little bit of challenge, because then those dependencies with pinned versions, like here at the bottom here, they are usually committed to the repository because you want to share them between the developers. Yeah? So this, like upgrading one or two or three of those dependencies can become a challenge, especially if you have to do it often. But, you know, like there are some critical security fixes. There are some new features that you want to use and you want to upgrade that. So there are solutions to that, like Dependabot. Anyone uses Dependabot on their GitHub account? No, that's somebody. So there are some ways of dealing with that. What it does is creates like a pull request in GitHub and tells you, okay, there is a new version of dependency. Please merge me, and you will update. I will update the dependency. This is already there in GitHub. GitHub bought Dependabot some time ago. However, there are some other challenges, like you have different set of dependencies for different Python versions. So this kind of depend-about approach will not work exactly in all the configuration, because it will only work on like one set of those, but you can have several, like Python 5, 3.6, 3.7, 3.8. They all might have a little bit different dependencies. And this works, this is like the general dependency approach for many applications. And Poetry and some other tools, they do make these opinionated decisions when they when you work with them, that you either work with library or with an application. And the behavior is a little bit different if you have either library or application, because for application you really need to end up with like install requires in the application, which will install dependencies in exactly the versions you specified. But for library, those install requires are just ranges, or usually just like lower limits. And why Airflow is different? First of all, Airflow is an application. I can prove that. I can show you the screen, and there are some people who know Airflow. I know they can confirm it's an application that you want to install and run, and it has a UI. It's also Flask based, so yeah. No Dash this time, and a little bit of JavaScript, which I hate, by the way. Yes, of course. Same story. But it is an application. You want to be able to install Airflow 2.2.2. This is the latest version. We released it like last week, and we want to install it today. But in 3 months, if somebody installs Airflow, we want to be able to install Airflow 2.2.2 the same way as we did now. It shouldn't change over time. So basically, it boils down to all the dependencies should be more or less fixed. Yeah, you shouldn't, because then somebody can release the dependency that you rely on, a new version of library that will break Airflow. We don't want that, and I have some stories about that in a moment. But unfortunately, Airflow is also a library. It's not only application, but it's also a library. Why? One of the reasons is we have like 70 different PyPI packages. Those are providers, because Airflow can interface with like 70 or 80 different services that it can talk to. Each of those services is a package, and each of those services has its own set of requirements. So there is Azure, for example, there, which has its own requirements. There is like Amazon integration. It has its own set of requirements. Docker, Drill, all the stuff. So we have a lot of those optional components, and we can install them all with extras, so-called extras, in case you didn't know that, like Apache Airflow, and then you specify which of those can use, and they are all optional, but there are 70 of them, which ends up with 554 transitive dependencies we have in Airflow. Wow, this is the end of a file requirements file for Airflow. Yeah? So it's quite a lot, I would say. And why library? Because Airflow users are Python developers. I mentioned before that developing for Airflow means writing Python code. And this means that, for example, if you are using a so-called JDBC operator, this is an example here, it's a class. It uses JDBC, imports JDBC hook, which is another class. And this JDBC hook imports JDB API. That's a package, one of those 500 packages that implements JDBC. And we have 500 of those a lot of those kind of dependencies. And the problem is that people who develop those DAGs, they want to have possibility of using newer version of libraries than when Airflow was installed. So we cannot pin them for applications. For application, you pin the dependency and you expect, okay, this application requires this dependency in this version, and that's fine. But if you are a coder and you are developing some code with Python, you do expect use newer version of those libraries when new features are released, and pinning them at installation time is not the best idea. So what challenges we face when we look at Airflow as an application? So first of all, operations guys, they want to install application Airflow consistently. They want to install it now and in 2 months, and it should install without breakage. But many libraries claim to have semver support, semantic versioning, which means, okay, I can safely upgrade this version 2.30 to 2.50 and nothing will break. Well, that's a lie. I mean, in many cases, that's a lie. we experienced that many times, that upgrading from 0.97 to 0.98 of a dependency broke our application, broke Airflow. So Semver is kind of, you cannot rely on it. We have many problems. One, the most interesting problem you also mentioned were Werkzeug today. This is like my favorite application, because 2 years ago, or 1.5 years ago, when we released 1.10.8, somebody 2 hours later released new version of Werkzeug, which broke the installation, which basically meant at that time that when we installed Airflow and somebody pulled the latest version of Werkzeug, which was not limited by Airflow, because we didn't know it's going to break our Airflow, it didn't work. So Airflow was broken by somebody else releasing a dependency. And we have completely no control over that. So we released 1.10.9 the same day, and the only change there was just limiting version of Werkzeug. That was the only version. And actually we broke Apache Software Foundation rules, because we are supposed to vote on the release, and it's supposed to last 72 hours before the vote is concluded. We have very, very, very strict rules on that, and we couldn't wait, because we just released new version and it didn't install. Like, wow, yeah, that was crazy. So we had no control over application installability. That was the problem, the challenge that we faced. And it was getting worse over time. We had many, many cases like that, including, I think today 2.2 is installing correctly if you just plainly install it in the way that you would normally install other applications. I'll come back to that later. But what are the challenges we are actually facing when you look at Airflow as a library? So first of all, we cannot pin those dependencies because our developers want to upgrade the new version. If you know how pip and dependencies work, in the package, if you specify install requires, which is the way how applications tell like which version are there, if you pin to a specific version, then you cannot upgrade this dependency. It won't work. People will refuse, especially now in the latest version. It will refuse to install a new version. And our developers who used Airflow as developers, they complained, why I cannot, if we pin something, why I cannot upgrade to the new version. Yeah. So, but, you know, like, yeah, okay, we could release Airflow more often and, you know, like pin to latest versions of those libraries, etc., etc. But that would mean that you would have to migrate Airflow all the time with newer dependencies, release. And the ops guys do not like that. If you ask them, they don't want to migrate every week or so. So our releases of Airflow are every 3 months, more or less, a release. And we release the set of these providers which are integrating with different services every month, more or less. I'm the release manager of that. Yeah, and the problem is also that, you know, there are some shared libraries which are shared between those different providers. So like one provider uses this version with those dependencies and the other with those. And then we want to make sure that it all works together. And also our users actually have their own custom code inside. They integrate with Airflow the same way. And they have the same libraries used in different versions. And they probably would like to upgrade those versions that we have. So this is a challenge if we want to join those two approaches. But also another set of challenges was like how to make the development environment work for Airflow. Installing, as you can imagine, installing 500 dependencies, including pandas, numpy, and few other scikit and whatever, which compiles on many platforms. This is a challenge. It takes like 30 minutes to install it from the scratch sometimes. So you don't want to install it too often. Developers have different versions of OSs, Linux, macOS, WSL2. We support all of those. We have about 10,000 unit tests that must work for every PR to be merged. We are very strict about that. We are very, very, conscious about the quality. It breaks sometimes, and we fix it continuously. It's an uphill battle, but our goal is that every PR is green, which means it runs all the 10,000 tests in all the different combinations like MySQL, Postgres, MS SQL recently, and Python 3.6, 3.7, 3.8, 3.9, 3.10. We have to support all of that, all those combinations. Crazy. And we have more than 300 active contributors every month. In total, we have 1,800 contributors for the whole project. That means a lot. And those contributors, they have to have the development environment, which is very close to each other development environment. This is a huge challenge, because if you have those many dependencies, how the hell, like, which version I have? I mean, works for me is like crazy. Keeping the same dependencies, it's extremely difficult. However, we also would like, when we develop, to automatically upgrade to latest version of all the compatible libraries that we have, because of security fixes mainly. Often we get a question from our users. I don't know, from you probably not. I don't remember. But we had these questions like, okay, I ran the scanner of all the dependencies on Airflow, and it showed me this many vulnerabilities. Yeah, please upgrade. Yeah, and then you have 100 of them. Yeah. So we want to proactively upgrade to those latest dependencies. However, the dependabot approach, where you install one PR, upgrading one dependency. If you look at how many dependencies we have, this is about like 20 PRs a week. If we would like to update them, literally, we have that many changes in our dependencies every week. It flows continuously if you look at that. And imagine how difficult it might be if one of those dependencies breaks something and you don't realize what it was. So, and the breaks are, if we would use the latest version always for our PRs, for example, then probably every second day we would have a breakage of some way, or maybe not second day, every second week, maybe, yeah. So we have to. These are our challenges. And on the other hand, those contributors are contributing code, and we don't want them. I mean, there is no one who actually, like, I don't want to manually go and upgrade those dependency every week. I mean, this is stupid. Yeah, this is not an interesting work. Yeah, and we don't want to move that on contributors, because they sometimes don't realize the consequences of these upgrades. Yeah, they don't test. They just like upgrade. And we also have some challenges for our continuous integration, because we run these 50 CI builds every day at least. We want to use latest dependencies. I talked about that. The new dependencies might break all PRs which people are making. So we have like 30 PRs. Somebody like Werkzeug case, that's really funny. Like, they released the version of Werkzeug, and not only the Airflow was broken, but all the PRs of all the people were broken, because nothing worked, because like it was like crazy. And even recent example, that's from last week. Moto 3 was released 2.2.15. Previously was 2.2.13. You would expect it's backwards compatible because of December. Yeah, like, we can safely upgrade to Moto. Yeah. No. It just broke our tests in the way that it was impossible to tell without going very deeply to understand what's going on. The problem was that it became suddenly a little bit more picky about the parameters you pass it to the tests. So that was only tests, because Moto 3 is a test library. But it expected us to give a little bit more realistic parameters in the tests, because our parameters were not realistic enough suddenly in one release. Yeah, and if we don't have a solution for that, that means that when they release Moto 3, it breaks everyone's PR. So 20, 30 people committing the same day, they will have a broken test, and they will not know why. I mean, and everyone will complain, and we'll get issues. And our Slack will be completely overrun by people who say, it doesn't work, the tests do not work, the test fail. Like, what? I didn't touch the code. Yeah? Like, it's crazy, it happened. I hate it. So the PRs that people are using, they have to use kind of like fixed set of dependencies. And that rings a bell a little bit like an application. Yeah? Application needs a fixed set of dependencies as well. And also, one important thing, if your CI breaks on the CI, you should be able to locally reproduce the whole environment and test it locally in order to fix it and see that it's fixed. So you have to have a way. But if you have 500 dependencies and you installed your Airflow 5 weeks ago, then probably about 300 of those dependencies are already out of sync. So like, and then like, should I update now on like when, which dependencies? Like, it's crazy. Yeah. And we cannot use Dependabot, by the way, because Apache Software Foundation doesn't allow it, because it's submitting code from outside of, which is not done by human or something like that. So now very quickly about the solutions. So if you look here, this is the key. So when you install Airflow in specific version, you also, oh shit, not that fast. So you also have to specify, and this is the only official way of installing Airflow, you also specify those constraint URL. This is like this is downloaded from GitHub, as you can see, GitHub user content. This is part of our repository, and this is a file which contains so-called constraints for all the dependencies. So we keep all the dependencies as open as we can. We don't use these poetry, any pip tools of anything. We just, in our repository, we keep a fixed set of constraints, versions of the packages, which will work for given version or given branch. And the important thing is constraints are not requirements. Like if you have install requires in a package, then it will be installed, and then you cannot upgrade this package, the other package, which pin dependency anymore. Which constraints is very different because they only work during the installation. So once you install specific version, it will install fine. It will use the right version, but then you can upgrade the dependency package as you want. There is no limitation, no problem. So constraints are just constraining you when the application is installed. So we keep the separate branches where we keep all those constraints. We have a specific tag for a specific release. So this one, as you see here, this is actually a branch, constraint 2.2, and there is a tag for this version of constraints. And then it downloads the constraints for a given Python version. And the nice thing of it is like it's kept in Git, so we keep the history of it. So we see when things changed. This is actually quite cool. And pip is perfect for that because all the other tools, I don't know why they don't have support for constraints. I mean, I know why, because they are opinionated and they said, okay, we don't support this kind of constraints. But pip is like a general tool that handles it very well. And here is an example, and I'm unfortunately is a little bit too small, but the thing is like, okay, so this is constraints main library. There is this file, and what it has inside is just a result of pip freeze, basically dumping all the dependencies that we have, plus some interesting comments how it was created, so that you can find the history of it. But what's really cool there is that we also have automated dependency upgrade thanks to that. So when you have PR coming to Airflow, it uses the latest and greatest set of constraints that we know it works. That's cool. But when we build the main build after you merge the code, it builds the same images, Docker images, with pip doing install with eager update, which means it will take the latest version of any package that is there available, starting from the moment you are like fitting your limitations. And this means that all the dependencies, all the 500 of them potentially, are upgraded in a single go. One go, all upgraded. And where all tests pass, it also automatically pushes or generates the constraint file and pushes it to the repository automatically. So basically it means that there is an automated process in our CI. If all the tests pass, it takes the latest versions and push the change to the repository. And this keeps, and if they don't, we see because the main build fails, and we fix them completely independently from all the PRs coming from all the different contributors we have. So this is like a snapshot of our CI, which does it. So there is like constraint building, constraint pushing, committing the constraints and pushing them. And this is more or less how it looks like. I know we don't see the details, but this is how we see. So, for example, this is one of the pushes which upgraded like a Flask app builder from 334 to 340, Mako from 115 to 116. And that was like one single commit that upgraded many at the same time. And we knew that it works because all our tests passed. It is not pushed until the test pass, all of them. And this is the kind of commit that is result of that. So there is like updating constraints. You see from which build it came, what was the commit that was built at the time, some explanation, and then you see the when it was generated and the changes. So this is the commit that is result of that. However, the cool thing is also that the constraints are the source of truth for all the development, because we know they are okay. They passed all the tests. The constraints are sitting there. So we have a Dockerized Breeze environment, and that's my That's my invention, the name. It's a breeze to contribute to Airflow. It's a very nice tagline, which I love to repeat. There is a video which is explaining how the environment works, but it is based on Docker images, which use the constraints, and basically anyone at any point of time, they can run a breeze build image, and it will, in an optimized way, pull all the images from registry as needed. If not needed, then it will only rebuild part of it, and at the end, everyone has exactly the same Dockerized container with all the dependencies in exactly the same version as in the main, without doing anything. It just happens automatically for them. So images are rebuilt and pushed automatically on our CI. So I don't have to do anything. Well, I do sometimes if there are problems, but normally they just, everything flows automatically with our CI. And what's important, those images are exactly the same images as we have in CI for development, which means that locally everyone has exactly the same environment to fully reproduce whatever CI failure was there. This is super cool with this number of requirements. And also as a bonus, we also update to the latest Python base images. Python releases base Docker images every now and then. And you would think like upgrading Python 3.6 to newer Python 3.6 version, like 3.6.7 to 3.6.8 is just bug fixes. No, it happened in the past that it broke our builds, it broke our Airflow. Once, even very surprisingly, Python base image released one day with the same version, the same number. 2 weeks later, the same version, the same number was released again, and it broke our builds. Exactly the same Python version. Why? Because they removed Python 2 from the image, simply. Like they didn't change the version of Python 3, which was there, but also there was Python 2, which was removed. Very interesting. So what are the benefits of this kind of approach? It works for like a really complex system, as we have in Airflow. Contributors, which we have many, and they don't know too much about Airflow sometimes. They just know some part of it. They very rarely have to deal with the dependencies. We have stable installation method for operations users. So Airflow today, using the constraint method, will install precisely the same way as it installed 2 months ago and 3 months ago, unless it was released 2 months ago. Yeah, of course. Then you have the ability to upgrade the dependencies. So if somebody wants newer version of dependency, they can upgrade it, no problem whatsoever. Most of our dependencies, unless those which are Apple limited, they automatically get all the latest security fixes without us even thinking about that. So basically, whenever we release an Airflow, for sure, the versions that we use are the latest compatible versions of all the dependencies we have, and this is something that people will get in their constraints. We use the latest base Python images with security fixes, but the important thing is like all the 300 contributors, their PRs will not break because somebody else released Werkzeug version 097, well, as it happened in the past, and we have full control over that. This is really cool. We even have the ability with these constraints, we even have the ability of retroactively update the constraints. It did happen once that even if you had a fixed set of dependencies, the things broke because setuptools stopped supporting Py2 to 3 in the latest version. So if somebody used the latest setuptools, one of our packages didn't install, and we had to manually change those constraints, and it worked. So we are able to kind of fix things for even if somebody breaks it. Yeah. Okay, that's about it. Thank you very much. Any questions?
Do we have any questions? Is the solution you discussed and described adopted elsewhere in the Apache Software Foundation or some other project?
Not that I'm aware of. Airflow is like super complex in terms of number of dependencies. There are not many projects, and the Apache Software Foundations are mostly Java projects. Historically, there are not that many Python projects. Bits and pieces of that, yes, they were reused because I work together with other Apache Software Foundation members, and we do exchange information. But the whole set of it, like as we need it, was I know only Airflow using something similar, and it's too complex as well. So right now we are starting a project to simplify this because a lot of Bash is used there, and I know everyone hates Bash except me. So this is also a story that we are going to implement right now. We have actually, that's an interesting story. We have 3 interns from, there is an initiative called Outreachy. Very cool story. It's an initiative that allows to the people who are underrepresented in IT, women, people from India, people from Peru, people from Nigeria, transgender, all the kinds of people that are underrepresented in IT. They got a scholarship to work on open source projects, and we have just today I got the confirmation. So we have 3 scholarships for people from Peru, India, and Nigeria who will be working on exactly this, converting this Bash stuff to Python to get better. And that's actually a cool story. I'm a mentor of those people. That's really interesting one.
Okay, another question. Was there any reason why you didn't separate application from package? So basically split your project into, depending on the use case, how user consume some library, split it into project and have maybe main project be an application and sub project be a library?
That's not easy because
I've seen it done, but yeah, I agree.
Yeah, it's no. The thing is, like, Airflow is like from it's and that was not my decision. I just joined Airflow 4 years ago, and it was 4 years or 3 years at the market already. So Airflow is very much how to say, is a Python platform, I would say. And there is a lot of dependencies between the code that people are writing in the DAGs and the code that is, for example, displayed in the UI. For example, there is, because the code that you are writing in the DAG is a Python code, it generates the dependency graph between different components, and then UI has to parse this code effectively. And this, in order to display this UI, that was historically, it's changing now. So we are actually moving away a little bit from that, because the web server part, the application part, is separated out from all the rest. However, there are other parts, like Airflow is fairly complex. It has scheduler, worker, a web server, and a few other components, and all of them at some point of time require to parse and load the same Python code, and this has to be executed in the same Python context. So those DAG writers will always, at some point of time, have to run the code which will be executed by the application itself. There is no, it's like very, very, very tightly intertwined. It's impossible. Like, we do work on separating it, but it's going to take like 3 years before we get there, I think.
Maybe another question. I didn't understand maybe one thing. Why did you separate branches, like for constraints? Like, was there any reason, any limitation? Because I've seen projects that successfully just have automated CI to generate requirements.
How many dependencies it had?
Like on that project, like maybe 50 to 100, but yeah, like.
So we have 500, and they are changing continuously. It's like, if you see those constraints, they are different for Python 3.6, 3.7, and 3.8. They have a different set of dependencies. For example, not only between branches.
Yeah, what I meant is, if you didn't separate them but kept constraints under tags, you would have user naturally use git tags to read constraints instead of learning about branches.
But they don't have to. I mean, they only use, users actually only use tags. They don't use branches. Branches are only for our development. So for example, when we have a branch of 2.2.1 and 2.2.3, 2.3.4, we can continue using the branch which was there. And the tags will be applied to this branch. But for the user who is installing like 2.2.4, for example, they will use tag. They don't even know branches. The branches are happening automatically. You don't even realize that they exist actually. It's just done automatically by the CI system under the hood.
Okay, maybe because you showed an example with pip install with constraints, I assume that's the user experience.
Yes, but that was there was actually a 2.2.2, which is a tag. It's not a branch.
Oh, okay, maybe I've seen it.
So that's yes, that might be my mistake that I didn't stress this. So users are only using tags. Branches are only for CI, actually.
You said that that Airflow is quite complex project. So how many people do you have in this, let's say, organization? How many contributors or maintainers? And is this structure is flat, or do you have, people assigned to the specific role, like a release manager or something like that?
Some roles are assigned like release manager, but it's kind of self-assigned. Like, I'm now a release manager. Yeah, this is how it looks like basically. So there is no fixed. And then for like providers, this is also a funny story. I'm the release manager for providers out of my own voluntary, decision. And every month I released between 20 and 70 packages, PyPI packages. I'm probably one of the people who released most number of packages by now, because every month I release like 20 or between 20 and 50 of them. But generally the structure is flat, super flat. This is a requirement of Apache Software Foundation as well. We don't have managers, we don't have hierarchy. Of course, people work in different companies, and the company hierarchy is there behind. But generally, everyone in project is either a contributor or committer or PMC member. I'm a PMC member, so those are those three kind of levels, I would say. And PMC member is mostly it's not a privilege, is kind of burden. Mostly, and we have more or less 20-ish, between 15 and 20 people who are very, very active committers. They commit daily multiple commits and review multiple others PRs, and about 300 people who are every month committing, more or less, something like that. Maybe less. Maybe it depends on the month actually.
Okay, so Airflow is both an application and a library. Do you think it would be like reasonable to adopt this approach to dependencies for libraries only, like having the CI and contributions in mind? Maybe it's a function of the size of your dependency tree or something.
I think maybe not exactly this. So Airflow is more kind of manifestation of where the usual tools that you use are not enough, like Poetry, Dependabot, which I mentioned today. They are perfectly fine for smaller libraries. They don't have these kind of requirements that we have, but the concepts behind that are pretty much the same. It's like the log file by Poetry is exactly what we do with our constraints, but it's committed to the repository manually and maintained with like Poetry upgrade or whatever the command is. So the concept is more or less the same. In our case, really the need came out of the like, boredness of having to update all that. Like it would be as a release manager, it would be a terrible, terrible job just to keep the dependencies upgraded all the time. I didn't want to do that, and usually when I do something like this, which is boring, and I see that, then I automate that. So this is my kind of work. And the Dependabot we couldn't use because it was too simplistic and too many of those PRs. The same with Poetry. We tried. I like Poetry personally, but it doesn't fit our case. It's just too opinionated. But the concepts which I'm talking about, like how applications should be treated, how libraries should be treated, how you should treat the consistent development environment for developers, those concepts are exactly the same everywhere. It's just a matter of like how you manage to automate that. And for small libraries or small projects, it should be perfectly okay to use existing tools which are out there. Yeah.
Thank you.
So, thank you.
Thank you, Jarek, once again.